Hi, this video serves as a continuation of the Euclidean geometry videos. So, since people have been complaining that Euclidean geometry is giving them some chest pains and sleepless nights, I've decided to post this video to give additional examples that will then prove useful when preparing for the grade 12 maths exam paper 2 in particular. So let's do it. The first question is asking us to find. Okay, let me first read the whole thing. In triangle ABC, F and G are points on sides AB and AC respectively. Okay, so D is a point on GC such that D1 is equal to B. So D1 is equal to B. It's very important to make note of certain things just to keep track of all the information that is given. So I'm just gonna use a different color to show that B1 and B and D are equal. So the first question is asking us, they are saying if AF is a tangent to the circle passing through points F, G, and D, then prove given reasons that FG is parallel to BC. Okay, so if AF, this line here, is a tangent to the circle passing through FGD, so it has to be outside and it touches the circle at one point. So the circle has to be passing through FG and D. That circle would look something like this. This would be the circle. Now they want us to prove, giving reasons, that FG is parallel to BC. Before we do that, we know the conditions that that must be met before we can conclude that FG is parallel to BC. So let me first draw a diagram. So if this is FG and this is BC, for these to be parallel, we have to prove that the alternating angles found between them are equal, or we can prove that the interior angles are supplementary. In other words, when you add this angle and this angle, they should give us 180 degrees. Doesn't necessarily need to be a straight line. It can also be a line that looks like this, where this angle and this angle, when added together, give us 180 degrees. If you can prove that these two angles give 180 degrees, then FG and BC would be parallel. And another way of proving that FG is parallel to BC would be to construct a line here such that this angle and that angle are equal. These two angles are known as corresponding angles. They form something that resembles a C shape. So if you can prove that this angle and that angle are equal, that would prove that FG is parallel to BC. Okay, now that we know that, let's try to attempt the question. Okay, if you look at F1, if you look at angle F1, okay, let me use black. If we look at F1 here, this angle, and also look at the angle inside triangle FGD, you'll find that they are equal. So F1, angle F1 is equal to angle D1. The reason they are equal is because of the Tanco Theorem. If you want to know more about the Tanco Theorem, you can check my past videos. I have gone into detail to explain what this theorem entails. It's Tanco Theorem. Just gonna abbreviate it. So we've proven that this angle is equal to that angle there. But we also know that but we also know that B is equal to D1 too. B is also equal to D1. We were given, so the reason would be given. Therefore, if this angle is equal to D1 and this angle here is equal to D1, therefore those two angles are equal. As a result, F1 is equal to B as well. And now that F1 is equal to B, it's safe to say that FG is parallel to BC, because these two angles are corresponding angles, and corresponding angles are some of the necessary conditions that will then permit us to say FG and BC are parallel. So we can therefore say, therefore FG is parallel to BC. The reason for that is because of corresponding angles are equal. It's because corresponding angles are equal. Yeah, so that's how you would answer this question. Now let's go to the next question. In the second question, it's said that it's given that AF over FB is equal to 2 over 5, and AC is equal to 2x minus 6, and GC is equal to x plus 9. Then calculate the value of x. I usually write the information that's given and try to see if I can find any relationship between the information that will then help me find the answer. So I will usually start with AC, and I will usually start with the information that has the value that I'm trying to calculate. So in this case, I would start with, say, AC over GC is equal to 2x minus 6 over x plus 9. AC is 2x minus 6, GC is x plus 9. And I also know that AF is equal to, AF over FB is equal to 2 over 5. That's given. It's the line parallel thingy. What do we call it? It's line parallel one side of a triangle. Yeah, we say line parallel one side of a triangle. That's what we call it. In fact, the line parallel one side of a triangle is actually the relation between AC over GC and AF, and AB over FB. I'm gonna show it. It actually doesn't relate with this one. It doesn't relate with this, but I'm gonna show it. I'm gonna show you now. So AC over GC is gonna be equal to AB over FB. Just use logic here. From A to C, you travel, like you take the whole line here, and therefore you should also take the whole line when you are writing on the other side of the equality sign. You should take the whole AB line as well. And then at the bottom we have GC. GC is only this small part here. So this means that on the right side of the equality sign, we're going to take this the FB, which is also this small line here. Hence we're going to have this, and then the reason for that is, I should have written it this way. Yeah, so this relation is justified by this line of reasoning. Okay, so now we can just substitute values here. So AC is known to be 2x minus 6 over GC, which is x plus 9, and AB is equal to, where is AB? Okay, we are not given AB, but then we know what AF and FB are. AF is 2 as given, FB is 5, therefore AB will be 7. So AB is going to be 7 because that's 2 plus 5. Over FB, FB is simply 5. As a result, we're going to have an equation to solve. So 5 times this whole thing here, we're going to get 5 times 2x is going to be 10x. 5 times 6 is going to be negative 30. And 7 times this whole thing here, this whole expression, is going to give us 7x. And 7 times 9 is going to be 9, 18, 27, 36, 45, 64, 63, 54, 63. Yeah, it's going to be 63. And then 10x minus 7x is going to be 3x. And 63 plus that 30, because when 30 comes to the side it becomes positive, is going to give us 93. And then we're going to divide on both sides by 3. We will then have x is equal to 31. So that's how you do these two questions here. So I'm not sure if there's anything I'm leaving behind that I should have explained, but then I think this is it. So if you liked this video, please leave a comment, like, and most importantly subscribe. Part 6 is going to be available too. It's on the left pop-up screen, and the list that covers videos that are based on Euclidean geometry is on the right side of the pop-up screen.